Hello, everybody, and this is lecture number 5, I suppose. Yeah, it's lecture number 5 on chemical reactions for grade 7 IGCSE students. Okay, so in the previous 4 lectures, we had covered a lot of things in chemical reactions, particularly the exothermic reactions. Okay. Now we are going to start with something called endothermic reaction. Okay, so let us get started with this today's session. So today's session we are starting with something called endothermic reaction. So name of the section is endothermic reactions. Now first of all, let us go by the definition. Now what is the definition of endothermic reaction? Endothermic reaction, the definition is a chemical reaction in which heat is absorbed and the temperature of the surrounding decreases is called an endothermic reaction. Now here you should find the contrast, okay? That is exothermic reaction that we studied, okay? In exothermic reaction, just the opposite takes place, okay? That is, the heat energy is given out, okay? And the surrounding temperature increases. Okay, so here it is just the opposite in endothermic reaction. In exothermic reaction, the heat energy is given out and the surrounding temperature is increasing. But in endothermic reaction, the heat energy is absorbed, okay, and the temperature of the surrounding is decreasing. Is that clear? So these two things are happening in endothermic reaction. Now let us take some example. The first example is melting of ice. So the ice absorbs heat energy to break the bonds between the atoms in the solid state. So ice is in a solid state, right? So atoms are very close to each other in a solid state. So heat energy is absorbed or taken in by this ice, and this heat energy is used to break the atoms, okay, so that the atoms can move apart and move more freely. And in the process, what happens? That ice gets converted into liquid, or you can say water. This is nothing but melting of ice. So in melting of ice, what is happening is the heat is being absorbed by the ice and the bonds are breaking and they are becoming loose so that the atoms can move still freely. And due to this, the atom becomes free to move and hence gets converted into liquid form. Okay. And one more thing you will see that, I want to add that over here. In this process, what happens is the temperature of the surrounding, okay, decreases. Okay. Why? Because the heat is, the temperature of the surrounding is increasing, okay, not decreasing. Okay. Why? Because the heat energy is taken from the surrounding, nowhere else, right? So temperature of the surrounding is increasing. Okay, this I want to add it over here. So now you must have understood why melting of ice is an endothermic reaction. So melting of ice is an example of endothermic reaction. Let us go for this one more example. Dissolving of ammonium nitrate in water. Now when you try to dissolve ammonium nitrate in water, again this is also an endothermic reaction. Why? Because heat energy is absorbed, okay, from the surrounding and the temperature of the surrounding, okay, dissolving of absorbed from the surrounding. Oh, 1 second. Dissolving of ammonium nitrate in water is an endothermic reaction because heat energy is absorbed from the surrounding and hence the temperature of the surrounding decreases. Okay, it will be decreasing. Okay, here also I'm sorry, it should be decreasing only. Okay. In endothermic reaction, the temperature of the surrounding is always decreasing. Okay, increasing happens, the temperature increases in the case of exothermic reaction. Temperature of the surrounding increases in the case of exothermic reaction. Okay. There's one more example, conversion of water to steam. Okay, so when water is getting converted to steam, that is also considered as a endothermic reaction. Why? Because in the liquid state, okay, the liquid water, it absorbs heat energy to break the bonds between the atoms of the liquid, between the atoms of the water, and they still move apart. They still move further apart to form gas or vapor. Now, in this process, you know very clearly that the heat energy is okay. Once again, the liquid water absorbs heat energy to okay. Here also the heat energy is absorbed. Okay, because the water particles, or you can say the atoms in the water, okay, they have to move apart. They have to go away from each other to get converted into vapor state. Okay, so that they can move still freely. So what happens? There is an absorption of heat energy taking place. And absorption of heat energy is nothing but a endothermic reaction. So conversion of water to steam is also an endothermic reaction, right? And here also you can see that when the water is getting converted to steam, the temperature is absorbed, okay, from the surrounding, and therefore the surrounding temperature will decrease. Okay, so this is also an example of nothing but a endothermic reaction. Okay, now here let me tell you, it will be right to call it as endothermic process and not endothermic reaction, because in a chemical reaction, okay, there's always some new product being formed. And in this particular conversion, that is water to steam, there's only a physical change of state taking place. No new product is formed. So it will be wrong to call this as a endothermic reaction. Okay, so you can better call this as a endothermic process. It's just a process, right? But not a reaction. Okay, fine. Next is, on the contrary, freezing of water. Now let us see what happens in the case of freezing of water. Water freezing means what? The water is getting converted into ice. That is known as freezing of water. So when water is getting converted into ice, what is happening is the molecules of water, okay, they are coming together. They are coming closer to each other, okay, so that they get converted into a solid form, which is nothing but a ice. This is what is meant by freezing of water. Okay, so liquid is getting converted into solid. Now in this process, you won't require any heat energy. Okay, you won't require any heat energy because the water molecules are going to come closer to form a solid. If they want to move apart, you will need heat energy. So here what happens, there's no absorption of heat energy because heat energy is not required. But on the contrary, when the water molecules come closer, okay, when all the atoms come closer to form a solid, what will happen that is that the heat energy will be released or heat will be given out. So freezing of water is essentially an exothermic reaction. It is not an endothermic reaction. Remember this. Okay? So freezing of water is not an endothermic reaction. Now here also, let me tell you, you cannot call it as a reaction. Okay, you can call it a process. Okay, fine. So it is an exothermic process and not an endothermic process. Okay, heat energy is given out in this case, right? Now let us move on to the next topic, which is applications of both the endothermic and the exothermic reaction. Now on the screen you can see the topic, application of endothermic and exothermic reaction. Okay, now let us take this first example. This is an example of self-heating can or food packets. Okay, now in the market you will see you get certain cans, okay, which are self-heating cans. Okay, so you may go to the market, you may find coffee or tea being sold in self-heating cans. What is the meaning of self-heating cans? The coffee or the tea inside that particular can will get heated automatically. You don't have to keep it on a gas or on fire. Okay, so that is known as self-heating can. You can find the same concept for self-heated food also. Okay, instead of coffee or tea, you may find some food which gets self-heated. Okay, you get it in such containers that the food will get heated itself. Okay, you don't have to put it on a gas or a stove or a oven. Okay, so these are known as self-heating cans or self-heating food packets. Right. Now, what happens in this packets or what happens in this can that we are going to see. Now, let us take this example. Can you see this is a diagram which is showing a self-heated can. Okay, this is a self-heated can. If you see the lower portion of this self-heated can here, can you see this portion? This contains a part at the lower side of the can, contains two compartments. Okay, in one compartment you will find some chemical, and in other compartment you will find water. Let us read out this first so that you will understand. So, what are the self-heating cans? Now, I was talking about these two compartments. Okay, so in one of the compartment you will find that calcium oxide is kept. Calcium oxide is a chemical which is kept, and in the other compartment you will find that water is kept. Okay, so in this particular part, at the lower part, at the lower side of the can, you will find an arrangement wherein this calcium oxide and water, they are kept separated by a thin foil. Okay, so they are kept separated by a thin foil and kept at the bottom of the can. The can itself has insulated wall. Now this can, has insulated wall. Insulated wall means no heat energy can escape nor enter into this can. Okay, so the walls of the can are insulated and it contains coffee in it. So in this remaining part of the can, you can keep coffee or tea, right? Now, on pressing a button at the bottom of the can, now at the bottom of this can you see there's a button-like thing. When you press that button, what happens is this foil, this thin foil, it will break open. Okay, it will break. So on pressing the button at the bottom, the foil breaks, and when the foil breaks, what happens is the calcium oxide and the water, they are now no more separated and they will mix together, and a chemical reaction will take place between them. So when the button at the bottom of the foil breaks, and an exothermic reaction takes place between the calcium oxide and the water, because now the foil is broken and calcium oxide and water will mix together and a chemical reaction will take place. Now, this chemical reaction between calcium oxide and water is essentially an exothermic reaction. It is an exothermic reaction. So this is the application of exothermic reaction. Now what happens in an exothermic reaction, you know very well. In any exothermic reaction, heat is given out. So when this reaction takes place, heat will be given out, and that heat will be used in warming up this coffee inside the can. Is that clear? So this exothermic reaction, when it is completed, heat energy is given out, and that heat energy, okay, is used in heating the coffee. So this in turn is used in heating the coffee, or you can say tea. Now the same principle can be applied for heating a foodstuff. Suppose there's some foodstuff kept in the container. You can do the same thing and get the heat released from a chemical reaction of this type between calcium oxide and water. It being an exothermic reaction, heat will be given out, and that heat can be used to warm up the foodstuff. Okay, so whether it is used in cans or whether it is used in food packets, okay, the purpose served is same. That is, the exothermic reaction is taking place and the heat energy is released, and that heat energy is used in warming up the stuff inside the packet or the can. Okay, so these are the examples of the application of exothermic reaction. Here we have made use of an exothermic reaction. Okay, but one thing you should notice that such cans are expensive, and many times even heating does not take place. So some drawbacks and also we can see in these cans. Okay, one of the drawback is it is expensive because there's a modification that has to be done. Second, it is seen that the tea or the coffee or the food stuff, it doesn't get heated evenly. Okay, so there's an uneven heating taking place, which is not good at all. Okay, so these are the drawbacks, right? Now let us take an example of cooling pads. Okay, now this is an application of endothermic reaction. This was an application of exothermic reaction. Now we are going to study the application of endothermic reaction. Okay, now cooling pads, they are also called as ice packs. Okay, now there are basically two types of ice packs. Okay, one in which ice is put in a bag and the ice melts, and melting of ice is an endothermic reaction, so it is going to absorb heat from the surrounding, and by that the surrounding temperature decreases. Okay, so that is what happens in an endothermic reaction. Now in this cooling pads, what happens is they use not ice. Okay, they use ammonium nitrate and water. Again, ammonium nitrate and water are kept separated in a compartment. Okay, so they are kept separated. So they are kept separated in two different compartments, you can say. Okay, so ammonium nitrate and water, they are kept in two separate compartments, and these two compartments are separated by a foil-like thing. Okay, by a thin foil. Again, the same thing is done by pressing of a button. Okay, this foil is broken up. When the foil breaks, these two chemicals, that is ammonium nitrate and water, they are going to mix together because they will come in contact with each other, and they will mix together and a chemical reaction is going to take place. Now remember here, ammonium nitrate and water react, and this chemical reaction is nothing but a endothermic reaction. Okay, now being an endothermic reaction, what will happen? The heat energy will be absorbed. So heat energy will be absorbed from where? From the surrounding. The surrounding is what? This cooling pad is kept on, suppose, your arm, on your hand. Okay, where there is some inflation. Okay, so from your hand, from your palm, that heat energy will be absorbed for this particular endothermic reaction to take place. And when heat is absorbed from your palm or your hand, what will happen? The temperature of your palm or the hand will decrease, and in the process you will feel good. I mean, that swelling or the inflation in the arm will be reduced. Okay, so this is how the cooling pads are used, and this is an example of nothing but endothermic reaction. So ammonium nitrate reacting with water, being an endothermic reaction, this is what happens. Okay, so I'll read out again for you. Cooling pads, endothermic reaction, they are also called as ice pads. Okay, here the substances taken are ammonium nitrate and water, and they are taken in two different compartments separated by a foil. When the foil breaks, the two reactants combine together and they absorb heat, as a reaction is endothermic reaction, and the heat is absorbed from the surrounding, creating a cooling effect. Now surrounding is nothing but your part of the body which is having inflammation. Is that clear? So this was something called application of exothermic and endothermic reaction. Okay, and let us move on to the question answers, but I think we'll move on to the question answers of this later in the next video. That's all for today. Bye.